Okay, so on Friday, you learned about asymptotes. That was the first time you've been introduced to asymptotes. Okay, and that was your 11-1. And so today what we're going to do, that's the worksheet. We need to look at the notes. Today what we're going to do is kind of dig a little deeper into this, and we're going to name the characteristics of this graph without looking at the graph. We're going to be looking at the I put my toolbox down here, and now because I was tired of fighting with it on the side, now I've got to kind of get used to where everything is. Anyway, we're going to be looking at just the algebra, just looking at the equation of it, or the function of it, and be able to tell the characteristics of this rational function. Okay, so let me clear this out, and then we'll be good to go. So this graph right here is a little bit busy, and it's kind of hard to see what's going on. So let me draw in a little clearer for you. Let me draw in the x and y axis. Here's the y axis like this, and here's the x axis right here. So the center, the origin is right here, this pink dot. Okay? So this one has, what we practiced on Friday was to see how much it moved. And where the asymptotes cross is kind of where you can tell, if that makes a good reference point, you can tell how the whole graph of the rational function moved. Okay? Remember, an asymptote is an imaginary line there that nobody touches it. Nobody crosses it, nobody touches it. And it has like water repellent on it. Okay? And here's another asymptote here. So nobody's touching it. Nothing in the graph touches it. Nothing crosses it. Nothing like that. What we have, we're going to talk about it more tomorrow, but we have a new term called a hole. These graphs actually have holes in them, usually just one, sometimes two. And literally, if you think about like taking a hole punch and punching a hole in it. Okay, however, in real life, it really wouldn't be that big. It would be just microscopic. Okay, it'd be just a teeny tiny microscopic hole. Okay? Okay, so we also can write the range. We can write it differently. We can say, or the domain. We can say all real numbers. Like this one, it's coming, remember, y'all know domain is from right to left. Okay? So you know you can use this graph, this black graph right here starts over here, and it goes right here, but it's not the x of the whole, so it jumps over the whole. Okay? So it's not the x of the whole. It's not the vertical asymptote. And so then this graph jumps over the vertical asymptote, and then it keeps going. Okay? So like in this case, the domain would be all real numbers except x is not equal to, they are saying the x of the whole is -1, and x is not equal to the vertical asymptote is 3. And like I said, we're going to talk more about the holes tomorrow, so don't worry too much about the hole. Okay, then the range, you could say it's all real numbers. It's really not the y of the whole, but they didn't tell us what the y of that whole is there. But it's also not the horizontal asymptote. It jumps over the horizontal asymptote. So not the horizontal asymptote. The horizontal asymptote is where? Y equals 1. Okay? So not equal to, make sure you put the not equal to sign. Okay? Okay, so now let's look at some of these characteristics. Okay, like I said, we're going to talk about the whole tomorrow, but the whole, you factor your function, and then whatever cancels out becomes your whole. And we'll talk about that tomorrow. Okay? The vertical asymptote, you set your denominator equal to 0. Denominator equals 0. Okay? So, once again, I've already put the notes from this morning into Schoology. And I forgot to record it. That's why I'm recording it now. But and it'll be in Schoology too, okay? So don't forget to look in Schoology. Okay, so we're going to practice that in a minute. Okay, let's keep going here. Okay, the horizontal asymptote. It's a little bit more, but it's easy if you'll pay attention, okay? Make sure you're off your phones. Make sure your earbuds are out of your ears. Okay, there's 3 different possible answers for the horizontal asymptote. Okay, remember the horizontal asymptote goes like this, right? Okay, you can have a y equals 0. You can have a number, which we'll talk about in a minute. Okay, and then you can have none. You may not have a horizontal asymptote. Well, how do you figure that out? Miranda, you got to sit up. Okay, how do you figure that out? Well, you look at the degrees. See the degrees right here and the degree right here of the first term. Okay, the numerator degree is a 2. The denominator degree is a 3. 2 is less than 3. So if the numerator degree is less than the denominator degree, okay, then your horizontal asymptote is y equals 0. And I'm going to give y'all kind of a little cheat sheet, okay, to use tomorrow. I'll give that to you tomorrow. If the numerator degree equals the denominator degree, see here, 2 equals 2, right? Well, then we need a tiebreaker. So we go to break our tie, we kind of back up and look at the numbers in the front. So here's an example, okay? 2 equals 2. So we back up and look at the numbers in the front, the coefficients. Okay, and so that would mean your horizontal asymptote is 3/5. So that's easy. If it's a tiebreaker, you go look in the front. Okay, and that's your horizontal asymptote. Okay, now we did, if the numerator is less than the denominator, it's 0. Well, if the denominator is bigger, no, if the numerator is bigger, okay, so like 2 is bigger than 1. 2 is bigger than 1. Then we get none for the horizontal asymptote. So that's the hardest part right there. And like I say, you're going to have a cheat sheet to help you every time, okay? Okay, to find the x-intercepts, you set the numerator equal to 0, okay? Numerator equals 0. If we back up a minute to find the, oh, it was on the other page. To find the vertical asymptote, the denominator was equal to 0. To find the x-intercepts, you set the numerator equal to 0. I'm going to work out 2 whole problems for you on this so you can see all this happen, okay? The y-intercepts, you plug a x into the equation. Plug x, plug 0. I should say that differently. Hang on. Plug, come on. Okay, plug 0 into every x in the equation. And that'll give you the y-intercept. In other words, where the graph is crossing the y-axis, where the graph is crossing the x-axis up here. Okay? Then the domain is all real numbers except it's not the vertical asymptote, which we just wrote a minute ago. It's not the x of the whole. The range is all the y values except it's not oh, that's wrong. It's not the horizontal asymptote. I didn't catch that first and second period. And it's not the y of the whole. Okay? I need to go in and fix that for next year. Okay. Okie doke. So let's work one. So on your notes, there's one example. So this kind of gives you the clues on what to do. Okay? Once again, today you're not going to have holes. Okay? So you know that you can do none on all of the holes today. Okay? Tomorrow we'll talk more about the holes. Okay, so you can factor So I already kind of told you they're not going to have holes. So this bottom can factor, can it? You divide by 3. So make sure you include your GCF over here. When we were adding and subtracting and so forth with those rationals, some of y'all were forgetting to include the GCF over here, and that was messing you up, okay? So then you have x plus 2. Now, just a little sneak peek into tomorrow, okay? You know if you have a hole, if you can cancel those out. I can't cancel these out right here because one's a plus, one's a minus, right? They'd have to be exactly the same. So we don't have a hole because it's not x plus 2, x plus 2. Or it's not x minus 2, x minus 2. Okay, so did anything cancel out? No. So we know we don't have a hole. Okay, usually what I like to do is do the horizontal asymptotes and the holes first. That's the smart thing to do. Do the h's first. If you'll remember, do the h's first. That will help. Okay, and I'll keep stressing that tomorrow. So let's skip down here and do the horizontal asymptote. Okay, because you really want to do the horizontal asymptote before you start to factor. So what are the degrees here? A 1 and a 1, right? What do you do when it's a tie? You look at the front. So there's a 1 here and a 3 here. So what is our horizontal asymptote? It's at 1/3, isn't it? Okay, so I already kind of drew this over here earlier, but it's just barely above the the x-axis, right? Okay, you just have the horizontal asymptote is just 1/3. Okay, now we've done the holes in the horizontal asymptote. Now you can just kind of start back over here. Do the vertical asymptote. You set the denominator equal to 0. You've got a couple of choices here. You can set 3x plus 6 equal to 0, or you can set the factored form of it equal to 0. Okay? Either one. Here you would say 3 equals 0. And you would say x plus 2 equals 0. Does 3 equal 0? No, so you get to mark that out. So what is x here? -2. Here, if you used the denominator before you factored, you would be subtracting, and then you would say 3x equals -6, and you would divide by 3, and you're still going to get -2. You're going to get the same answer either way you do it, okay? So our vertical asymptote is at -2. So like if we were doing this problem, our vertical asymptote would be over here. Squeaky squeak. Okay, be over here at -2, right? Okay? These red lines would be, they're wrong now, but okay. We've already done the horizontal asymptote. Maybe we should have put a 2/2 and then say then look at the 1/3, you know, because 2 and 2 were tied. Okay, to find the x-intercept, you set the numerator equal to 0. What's in the numerator? X minus 2. So what is x? 2. So an x-intercept, let me erase this over here. Okay, so we have, I just have a little bitty sketch over here, but an x-intercept is where does the graph cross the x-axis? It's crossing it at 2. Okay? Okay. Then the y-intercept, you plug a 0 in for every time you see an x. So we're going to have 0 minus 2. And then we're going to have 3 times 0 minus 2. Or you could do it from the factored form. Okay? Is it plus 2? Yeah, it is, isn't it? Okay? Either way, you get a -2 on the top, right? And did I do that right? That's a 6, isn't it? Okay, I knew something was wrong there. Okay, hang on. Come on. Okay, so that's a plus 6. My pen's a little off, I think. Okay, so you have a -2 on the top. That becomes a 0, doesn't it? And so you have a 6 on the bottom. You have -1/3. Here, you have a -2 on the top times 3 times 2 is -2/6, which is -1/3. What we're going to find out tomorrow, it's better to use the factored form once you cancel out stuff, and you'll see that tomorrow. So our y-intercept is at 0, negative 1/3. So our y-intercept is at barely at negative, a little tiny itsy bit below. It's at negative 1/3, right? So that's all we really know about this graph. We know the x-intercept, we know the y-intercept, and so you have to just kind of sketch it. We're not asking you to sketch it today. That'll be another day. But you kind of have to do that. So you kind of assume then that this kind of makes a mirror image, so to speak, over there in that other quadrant. Okay, now the domain, I like to just say the domain is all real numbers. It's not equal to the vertical asymptote and not equal to the x of the whole. Okay? It's all real numbers, but it's not the vertical asymptote because it jumps over the vertical asymptote. The vertical asymptote doesn't have anything on it. So what is our vertical asymptote? Look back up there and tell me what it is. Or tell me what's the vertical asymptote? Negative 2? Okay. And we don't have any holes, so we didn't have to do that, right? Okay. Then the range is all real numbers, except y is not equal to the horizontal asymptote. What was the horizontal asymptote? 1/3, because range goes from bottom to top. So it's going to skip over that 1/3 and then keep going because nothing can touch that 1/3. And then it's not equal to the y of the whole, which we don't have that. We'll deal with that tomorrow. And so they're saying right here, you put the vertical asymptote here, okay, negative 2 and negative 2. You put the horizontal asymptote here, 1/3 and 1/3. I think it's easier to write it like this, but then some test questions or whatever might have it written like that. And so I kind of want to show you both ways. And this will all, right now you're probably feeling a little confused, a little overwhelmed. This will all get better, I think, tomorrow. When you're kind of doing it, you'll have a day's worth to do it. Okay, so now let's look at your worksheet, which I'm going to pass around to you. Let me see if I can figure out how to pause this thing here. What we're going to do is we're going to work number 3, okay? So we're going to work number 3. Okay, so on number 1 and 2, they give you space over here to do it, to show your work. But on 3 and 4, they're trying to kind of train you. They're trying to get you kind of off of that. But they're still giving you enough room. Okay, so the first step is to see if it can factor. Can it factor? No, it can't factor. Okay, so the second step is, so we know this is a none here. Okay? This, because it can't factor, and I've already told you that the first 5 that you're doing today don't have holes. You'll understand holes tomorrow, okay, when I teach it to you. Okay, do the horizontal asymptote next. So let's look at the degrees. We have an x to the 1st degree over an x to the 3rd degree. So our numerator, let's write that over here. Our numerator is 1, it's less than our denominator, which was 3. So what kind of a horizontal asymptote do we have? Look at your notes. It's not tied, so it's either a 0 or a none. 0, okay. When the numerator is smaller than the denominator, it's 0. Okay, now we can kind of back up and we can do the vertical asymptote. You set the denominator equal to 0, and this is one reason I picked this question, okay? You might want to, I probably wrote that in the wrong spot. You might want to put denominator equals 0 right here. Whoops. I know, I got it. Okay, put denominator equals 0 right here because we need this little workspace right here. So, Oh, that's number 5. Hang on. Okay, here we go. Okay, so we're going to put denominator equals 0. Okay, so here's our denominator. We're going to say x to the third plus 1 equals 0. We're solving for x. Let me move this up so y'all can see it. No, it's not hard. So we're going to subtract 1. We have x to the third equals negative 1. Okay, you don't divide it. Okay, how do you get rid of a third root? You cube root it, not cube it. Cube it would mean multiplying it by itself 3 times. Cube root it, okay? Cube root. So we're going to cube root, okay? Cube root, cube root. So what is the cube root of negative 1? Yeah, negative 1 times negative 1 times negative 1 is negative 1. So the cube root of negative 1 is negative 1. Okay? So most of the time they're not like that. They're easier. Okay? That's why I picked this one to work with you. Okay. Now, let's do x-intercept. How do you find the x-intercept? The numerator equals 0. The vertical asymptote, the denominator equals 0. The x-intercept, the numerator equals 0. So what's in our numerator? 7x, right? So you say 7x equals 0. Divide by 7, so x equals 0. Okay, y-intercept. So we have 7x over what? What's our, I can't see it. What is it? It's x to the third plus 1, right? Okay, so you plug in a 0 for every x. Okay, what's 7 times 0? 0 divided by, and then that's a 0 plus 1, 1 is what? 0. Okay, so our x-intercept and our y-intercept are at 0. Okay, our domain is what? It's all real numbers, except it's not the vertical asymptote, and it's not the x of the whole, which this one doesn't have a whole. Okay, what's the vertical asymptote? Y'all go back up there and tell me. X equals what? Negative 1. Whoops, that messed up. Okay. Okay. What's the range? Okay, so the range is all real numbers, but it's not the what? It's not the horizontal asymptote. Okay, not the horizontal asymptote. What's the horizontal asymptote? X equals 0. If we had a whole, it would also not be the y value of the whole. Okay, so now you are going to do 1 through 5. Let me back up to number 1. You're going to factor this. So you're going to have two vertical asymptotes. I know, and because I just saw that and I thought I'd help you out on that one too. Okay? You're going to factor that. That's an easy one to factor. You're going to have 2 vertical asymptotes. Okay? Now let me back up to number 1. When you're trying to find the horizontal asymptote, which that's what you should do first, you need to use an x to the 0 power and a 1. Because we don't really have an x up there, do we? So use a 0 and a 1 when you're comparing the degree of the numerator to the degree of the denominator. All right? Okay.